In mathematics, groups and coding theory is a very important topic. So today we start with the some topics from groups and coding theory. Now the first unit is integers. Now this is the algorithm that we have to study to find GCD of two positive integers, which is known as Euclidean algorithm. Now see, for any pair of positive integers a and b with a greater than b, we may find GCD of ab by repeated use of division to produce a decreasing sequence of integers r1 greater than r2 and so on as follows. So what is the actual process? Now for the given two integers, first see whatever is the number bigger, consider it as a and smaller number as b. Now we divide a by b, then after division we get some quotient say q1 and remainder r1. So a equal to bq1 plus r1 by division algorithm, where 0 less than r1 less than b. Again, b is greater than r1, so we apply division algorithm once again. So b will be r1 q2 plus r2. Now here as r2 is a remainder, it is less than r1. So condition is 0 less than r2 less than r1. Again we divide r1 by r2. So r1 will be r2q3 plus r3. So the remainder r3 is greater than 0 and less than r2. So continuously we are getting remainder which are less than previous remainder. But as remainder cannot be negative, finally it should be 0 somewhere. So when we get the remainder 0, then the last non-zero remainder is nothing but GCD of a and b. So this is the Euclidean algorithm. Now see, here we have considered that a is greater than b. So sometimes a may be equal to b also. But if a and b are two numbers which are equal, then in that case obviously the number itself is the GCD. And if we are getting r1 equal to 0 in the first step only, then in that case smaller number is the GCD. For example, if I consider a is 10 and b is 5, then here in the first step itself I will get 10 equal to 5 into 2 plus 0. So I am getting r1 equal to 0 itself. So no necessary to do it further. Directly as 5 divides 10, we can say that 5 is the GCD of that two numbers. Now see how to write 10. Now from equation 2 we can write 10 is equal to 100 minus 15 into 6 by shifting 15 into 6 on the left hand side. So here we have substituted the value of 10 from equation number 2. Now the whole bracket we have to multiply by 1. Now 100 into 1 is 100, 15 into 6 into 1 is 15 into 6. But outside bracket there is negative sign. So changing the sign, it is 15 minus 100, minus minus it becomes plus 15 into 6. Now here by taking 15 common, we get 15 multiplied by 1 plus 6 plus 100 into minus 1. So it is 100 into minus 1 plus 15 into 7 by rearranging the terms. So we have written 100 initially and 15 after that because we have to express GCD in the form of 100s plus 15t. So comparing it with 100s plus 15t, we get s is equal to minus 1 and t is equal to 7. So this is the linear combination as required. So we have finally expressed 5 as a linear combination of 100 and 15, which are the given integers. Now similar way, this is the second example. Here we have to find GCD of 2329 and 3151 and we have to express it in two different ways. Now similar to previous example, here also we have to use Euclidean algorithm. That means we are applying division algorithm repeatedly. Now out of the given two integers, 3151 is bigger than 2329. So we consider A as 3151 and B as 2329. 2329. So divide A by B, then we get some quotient and remainder. So after dividing 3151 by 2329, we get 1 as quotient and 822 as the remainder. Continuing in this way, finally we got remainder as 0. Now the last non-zero remainder is 137. So the GCD of 3151 and 2329 is 137. Now the another part is we have to express that GCD as 2329s plus 3151t in two different ways. Now the first way is similar to previous problem. So for that we give numbering from second last equation as 1, 2, 3, 4 and so on. Now from second last equation we write 137 is equal to 822 minus 685 into 1. And after that substituting the values for remainders, finally simplifying, we get 137 is 2329 into minus 4 plus 3151 into 3. So comparing it with 3151t plus 2329s, we get s is minus 4 and t equal to 3. Now this is one way of expressing GCD as a linear combination. Now as already we have seen it in the remark, another way to express 137 as a linear combination is that in the previous linear combination, what we do, we add multiplication of given two integers and we subtract it. See how to do this. So we add and subtract 2329 into 3151 from the previous representation and then we rearrange the terms. So 137 is equal to 2329 into minus 4 plus 31513. This is our previous linear combination. Now in this we are adding 2329 into 3151 and again we are subtracting to maintain that equality. Now from first and third expression we can take 2329 common. So it is 2329 into bracket minus 4 plus 3151 plus from second and last terms we can take 3151 common. So in bracket it will be 3 minus 2329. So doing that addition subtraction we get finally it is 2329 into 3147 plus 3151 into minus 2326. So again comparing it with 2329s plus 3151t, we get s is equal to 3147 and t is equal to minus 2329. So if you observe the previous values of s and t, they were minus 4 and 3 which were different. So this is another linear combination that we are getting. So in this way you can find many representations. Now you can verify your answer also. So just do this product and add them. So answer must be 137 only. Then the linear combination we are getting is correct. Now one more example. Show that 497 and 3015 are co-prime. Now in this question it is not given that we have to find a GCD. But if you know the definition, then immediately you understand that you have to find a GCD. So what is the meaning of co-prime integers? It means they are relatively prime integers. Means their GCD is 1. So showing co-prime or relatively prime is nothing but you have to find that GCD and that GCD must be 1. So to find the GCD, again we apply the Euclidean algorithm, that is applying division algorithm successively. Now as 3015 is bigger than 497, we divide 3015 by 497 and write it as 3015 is 497 into 6 plus 33. Again dividing 497 by remainder 33, we get 15 as quotient and 2 as remainder. Continuing in this way till we get remainder 0. Finally we get 1 as the last non-zero remainder. So we can say that GCD of 3015 and 497 is 1. It means we can say that 497 and 3015 are co-prime integers.